Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
Okay, now that we have a better understanding of how to better visualize images using a better minimum and maximum value, working with the color schemes, color layout, working with thresholds, masking our images so that we only display the locations of interest within our region of interest. Let's continue with that thinking and that kind of work, where we initially just focused on the normalized difference vegetation index. Let's try to look at it from an urban area or built up area perspective. So what we want to do is to remember with the normalized difference vegetation index, we identify locations that has either high vegetation mass or very healthy vegetation. And we look at locations that is the opposite, where there's very little vegetation mass or where there's very poor vegetation in terms of its health. So that's what we took it from an NDVI point of view, is we focus on vegetation and identifying areas of, as I said, good vegetation and bad vegetation, if I can use that terms very loosely. So I want to do the same with build-up, because that's what we're quite interested in, is to find out where is the built-up areas within my region of interest, and how has that evolved over time? Is there areas within my region of interest which recorded a significant increase in build-up, and vice versa? Or is there areas in my region of interest that experience a decrease in built-up areas? So that's what we want to focus on, is that part of my region of interest. And there's a number of different indexes that have been proposed in the literature. And there's a number of studies that you can go and find. Just Google them. I maybe will add one or two of them in the comment section. Where we with the NDVI, there's one or two variations: the enhanced vegetation index, the normalized difference vegetation index, but they're not that different from one another. But with the build-up indexes, they're quite different. And the main problem with the build-up index is that it's a resemblance to bare soil and to soil. So it creates that problem, especially if you have a region of interest like what I have, where there's a lot of bare soil, and then the two gets very confused. So a lot of all these indexes that has been proposed try to detangle, try to break this link between bare soils and build-up structures, but it's very difficult, because in many cases the spectral signatures are very similar. They are very similar. So we go back to our script. The first one which you normally find in literature is this normalized difference build-up index. That's the typical one that you find in the literature. Okay, as I said, there's many of them. I think there's about 10 of them that you can find. This particular study, if you go to this particular study, a review of spectral indices for built-up area extraction using remote technology. You just look at this particular, there's a number of these articles. If you just look at them, this particular one, if you go down to whatever page it is, 15, there we go, page 5 of 2022, or page 391 of the journal itself, you can see there is a urban index, a normalized difference built-up index, improved NDBI, but NBI. You can see there's a whole lot of these indexes, and all of them, there's the specific studies that they cite, and all of them have to do with generating the index for build-up areas that is separate to bare soils, that don't mix the two. And you'll see in most of them, not all of them, most of them, they include the shortwave infrared options 1 and 2 and the near infrared. You'll see near infrared, shortwave infrareds, near infrared, there's a shortwave, there's red shortwave infrared, near infrared. So they make use of a number of variables, bands within, this is Landsat, but you can use the same Sentinel. It's not a big difference. And so you just use the corresponding Sentinel bands where this is Landsat. But you'll see most of them is the red shortwave infrared, near infrareds. That seems to be the predominant three. There's IBI. I don't know what the IBI stand for. We'll go and look at it. It's an NDBI minus the SAVI plus the this plus divide by 2. So there's a whole lot of these bands, indexes. There's a build-up index. There's a normalized build-up. I don't know what all these abbreviations now means. But you'll see there's a whole lot of these build-up area indices that you can use. And I think that, that it's still counting. So, but we normally start with a normalized difference build-up index. We normally start with the normalized difference build-up index. That's the one that we generally start with. Okay, so remember we've got the normalized different vegetation index. We've done that. Okay, we're happy with it. We can do the extended vegetation index. We can do that one. There's 1 or 2 water indexes, snow indexes, and all of these sort of things. We're going to get to that. But for now, we have our normalized difference vegetation index. Okay, so now we're going to do the normalized build-up index. Now, just remember we do the same methodology as we use with the NDVI. So the normalized build-up index, if we look at this study, let's have a look and see. There's a normalized difference index. Okay, there they are. So it is the shortwave infrared minus the near infrared divided by the shortwave infrared plus the near infrared. So we're looking for the shortwave infrared and we're looking for the normal near infrared. That's the two. Sorry, that's the two that we're looking for. That's the formula. So we specify the shortwave infrared. In this case, we're using the second one, shortwave infrared 2, okay, which is band 12. And go to your, if we go to Earth Engine, we go to our platform, we go to code editor, and we go, sorry, not code editor, we go to data sets, we go to Sentinel. It's very, very slow, apologies. While this is waiting, so we've got, and then we have our near info. We define our 2 variables or 2 bands as per the formula. As per the formula, we define our 2 bands. See if this is now, yep, it's now done. Sentinel 2 and surface reflectance. And there we see there's a 2 shortwave infrareds, is 11 and 12, and near infrared is 8. So near infrared is 8, and then we have our formula. So we add, first of all, we subtract the 2 ones, and then we add the 2 ones. We first subtract shortwave with the near infrared, and then we add the 2, and then we divide. Let's say first shortwave, subtract near infrared, shortwave, and plus. Okay, so we're following the order, and we create a new variable, which is the NDBI 2024 and an NBDI 2028. Okay, so there's our 2 normalized difference build-up indexes for 2024 and 2028. Okay, then I go through the same process as I've done with the NDVI. I generate the minimum and maximum values for my images, for my NDVI images. Okay, so let's have a look and see. There's the minimum value for the NDBI is minus 0.5 and positive value is 0.23. See, I've adapted my minimum and maximum values based on the values that I've now calculated using this min-max function. Okay, I use the min-max function. Again, I use the scale 900. That's optimum for my images, but again, it may be a bit different from your images, so just have a look at them. Okay, I'm using 900 as my scaling. I print them, which is this value here. I then substituted it back into my visualization parameters, and then I've created my colors. Okay, so green would be 0.5 to this side, and positives will be on this side. Okay, so that green will be minus 0.5, blue will be the next value, um, and so forth and so forth. So um, you're welcome then to change this color schemes as you please. You're welcome to play around with this color scheme, and let's see what it looks like. There's our, okay, so let's have a look. It's gonna happen very soon. There's my color schemes. Okay, let's go a bit out of there, make it a bit bigger. So we can see my whole region of interest. There's the colors. There's the two images. So that one is the 2018. Okay, well, it's happening very slowly, but it's happening while we're waiting for it to load. Okay, so I've used my min-max code to generate my min-max, and then I adopted my color schemes. And again, I played around with the color schemes, increase it, decrease it, play, change the colors itself, the where they fit in the order, the ordering, and all sorts of things. Okay, so let's have a look. That's 2018, and that's 2018, sorry, and that is 2024. That's 2018, and that is 2024. That's 2018, and that is 2024. Now let's quickly compare the NDVI and the NDBI values with one another. That's the NDVI value. That's the image. That's the NDVI, meaning the vegetation index. It's going to happen now sometime soon. And that is the buildup index. That is the vegetation, and that is the buildup. One would assume that these two will be inverse related. So where there's bare soils or buildup, you'll have low NDVI values. And where there's high NDVI values, there will be low soil and low buildup. So we'd assume this inverse relationship between the two of them. Okay, we would assume this inverse relationship between the two. Okay, and that's why this is inverse to the NDVI. You have green on this side, and with the NDVI, we have green this side, red this side, and with the NDBI, we have red this side. Okay, so we would assume it is an inverse relationship between the two. Okay, you can see there, yeah, yeah. So we've played around with it, whether this is the best available, most optimum solution, who knows? This is just what I've presented. And again, that's up to you to go and have a look. Obviously, we can use the inspector. So let's just click on any place here. Let's this place here, and you'll see all the values we'll see. So for this place here, there's the spectral signature in 2024. There's the spectral signature in 2018. You see it's, yeah, not that different. Yeah, been a change, but not that significant change. There's the NDVI value in 2024, 0.09. There's the NDVI value in 2018, 0.14. So that's a decrease in NDVI value. Let's have a look, decrease of 0.4. Let's have a look at the NDVI. NDVI was 0.10 in 2018 and 2014. You can see that inverse relationship. So the NDVI value decreased. The NDVI value decreased from 0.14 to 0.9. On the other hand, the NDBI value increased from 0.10 to 0.18. You see 0.8. This one, how did that increase? 0.04. So yeah, can't compare the two. But anyway, so that shows you the inverse relationship. So those locations that recorded an improvement in its NDI value will necessarily record a decrease in its NDBI value, and vice versa. Okay, so our color scheme is just the opposite of the NDVI color scheme. Anyway, so yeah, so that's the NDBI value. It's supposed to indicate build-up areas, but as you can see, because of the lots and lots of bare soils that I have, it's never going to give you that. It's never going to give you that. So, so I didn't even actually go much further with this particular index. I just basically created a visualization of the two indexes itself. I'm not going to go much further, not spend a whole lot of time with it. But what is important about the NDBI, what's important about the NDBI is that you use it to create what we called a build-up index. A build-up index. Sorry, that should be normalized difference build index. Okay, or BU, build-up index. Okay, so you need the NDBI and you need the NDVI to calculate your build-up index. Okay, so if you look at here, the normalized difference build-up index is your normalized build-up difference build-up index, the one that we just created, minus the NDVI, minus the NDVI. So in my case, to calculate it, I have to take the normalized difference build-up index and I subtract the NDVI. Have a look here. Normalized difference build-up index and I subtract the NDVI. That's exactly what I do here. Okay, and I create a new variable or new image, which is the build-up index, which is normal, the new build-up index. Okay, so that actually should be build-up index, not BI. It should be the build-up index. I just put a U there, so it should be an I. Anyway, that's just semantics. So I've got a build-up index. How do I calculate? I take the normalized difference build-up index that I've just calculated and I subtract the NDVI, and I calculate it and I give it a name. And I do that for both. And I do that for both. Okay, so this is what I'm interested in. The normalized difference build-up index, given the amount of sand that I have, bare soil that I have in my region of interest, are going to be of no use. So I'm not going to hana with it. I'm not going to spend a lot of time with it. But I needed to calculate my build-up index. Without that, I cannot calculate. So you see where the NDBI and where the NDBI fits in. It fits in not on its own per se, but if I combine the two, if I subtract them, I should get what they call a build-up index. Okay. Then I'm going to display the build-up index. Okay, I'm going to display the two build-up index. And again, what is my minimum value and what is my maximum value? I use my min-max script. I use my min-max script. Now, in this case, because I subtract two indexes, it not necessarily mean that the values will lie between -1 and 1. Remember, because the previous two are normalized indexes. Okay, normalized difference vegetation, normalized difference buildup. They are normalized, meaning you plus and you subtract, and therefore the values by definition would lie between a -1 and a 1. So that's what normalized means. You force the numbers to lie between a -1 and a positive 1. Now here, I'm subtracting two normalized images. So that means the values may not necessarily lie within -1 and 1. So you sort of blind what the values will be unless you individually, you as your inspector individually. Let's go and have a look at it. And that's why I'm using, again, this is where your code comes in wonderful, because now it will give you a definite number. Okay, so again, still using the 900, still using the 900 scale. And I calculate it. Let's go and have a look. It appears in my console. There's my build-up index 2024. Minimum value -1.228. I include that as -1.3. And the maximum value 0.08. There it lies, 0.08. So that's how I derived that values. I derived that values by using my min-max script. Using my min-max script. Okay. So that's, as I said, quite neat for you to know. That's quite neat for you to use. And I would generally recommend, not just in this particular case, but I would definitely recommend using the script. It works a charm. And then again, there's my color scheme. And again, that's just working, changing the number of colors, changing the order of the colors. And this is what I get to. So I'm going to subtract that. That's for that one and that one. Let's wait until it loads. Okay. Now, you see, that looks already much better. That looks already much better. That looks already much better. Then my normalized, the NDBI. Then the NDBI. Okay, so that's 2018. That's 2024. That's 2018. That's 2024, 2018. You can see 2018 much more red, much more red. But at least it's just not red. If I compare the NDBI, that's the NDBI. You can see, and that's the build-up index. You can see the build-up index is for sure. It's for sure an improvement on the NDBI. Let's have a look at it and compare again. The NDVI, that's a build-up index. And there's the NDVI, the build-up index and the NDVI. So the build-up index is already a significant improvement in my build-up, in my NDBI. Okay, so that's why I said I'm not going to honor with the NDBI. I'm not going to spend too much time and effort on the NDBI because it just basically paints everything red because of the number of bare soils. And that's why I want to calculate the build-up index by subtracting the NDVI. You still get a lot of red, but not as much. But still, you can see the impact of the bare soils. You can see the impact of the bare soils. So if we drill into my town, if you drill into my town, let's have a look and see. You see it indicates the build-up area quite well. Let's just quickly see. It indicates the build-up area quite well. So if I open up my Sentinel 24, see there's the build-up area, there's significant build-up area, there's significant build-up area. So if I go the build-up area, build-up index, sorry, it does take a bit of time. Sorry, there's my build-up. You can see it does fit my build-up area. It does fit my build-up area, but you can see so does it fit all the bare swell. You see the bare swells there? And you can see the bare swell. You can see the bare swell. So it doesn't discriminate between bare swell and build-up. Again, it gives you the sense of the spectral reflectance being so similar between build-up and bare swell. So let's quickly have a look and see the normalized, the NDBI. You can see the NDBI, how that looks. There's the NDBI. I made it like a brownish white color, but you can see again, similar. And there is my NDVI. There's my NDVI. You can see also that brownish color. So all three of them actually present the build-up area fairly nicely. You can see the build-up, but you wouldn't know that this is build-up if you don't know it's build-up. So if I just display this, give you this image, and you have no clue about this location, you wouldn't know that's build-up. I know it's build-up because I stay here, so I know it's build-up. So they don't actually, it's not unique. You see all these other colors. It's not NDBI, you can see it's not unique. That and this looks exactly the same. So you wouldn't know this is build-up and this is bare soil. It doesn't discriminate between the two. So not even the build-up index, if we go there, the build index discriminates between the two. So you wouldn't know that's bare soil versus that is urban area. You wouldn't know if you don't know. That makes sense. I know because I know because I stay there. But you can see that it is possible to discriminate certain locations from one another. Okay, it's possible to distinguish between certain locations. There's certain places where you can say that's for sure not build-up area. Okay, the red could be build-up of bare soil. But obviously these green areas, blue areas, white areas, brown areas, that we can safely say, listen, no, that's not build-up areas. Only the reds are build-up areas. But you can see, according to this, if we assume that red is build-up, then the whole place is built, almost the whole place is built up. And you would be terribly wrong. I think you get the idea. I don't want to belabor the point, but I think you get the idea. I think you get the idea. Then we created a temporary difference build-up index. Okay. And that's how that looks. Let's have a look. But you see, I didn't maximize the color schemes. I didn't maximize the color schemes. I just used it a -1 and a 1. And you can see the boring nature of the map. Similar to NDVI temporary difference, the boring nature. So what we have to do is go and see what is good values there. So I'm just going to pop it in there. And I'm just going to say it's my subtract BU. That's the image. Subtract BU. That's my image. And then here I'm also going to say, yeah, let's leave it. I'm in subtract BU. Max subtract BU. Let's just change that. Otherwise, yeah, that's if you copy and paste, please make sure you change all the places where that needs to be changed. Okay, so now I'm going to calculate the min-max value for this build up temporal difference image. Okay, so I'm going to run it. I'm not going to worry about unlocking. I'm just worried about this values now. Okay, so let's have a look and see what the numbers look like. See where they are. Where are they? Build up temporary difference. Is that the one that we're looking for? Build up temporary. Yep, build up. Build up temporary difference. That's what we're looking for. Build up temporary difference. There it is. Build up temporary difference. You'll see we've got -1. It's actually -0.67. Let's say -680. Hey, minus 0.68. Minus 0.6 and a maximum 0.69. Let's make it, yeah, let's make it 0.7. 0.70. So I have amended those minimum maximum values based on my min-max calculations, that I've done here. Okay, so I've just done that. I haven't changed the colors, the palette. Let's run it again and see what that looks like. Just make a mental note of how that image looked before we did this. Let's deselect all these others, otherwise it's going to take forever. Otherwise it will take forever. Let's make it bigger. The image that should appear now would be, let's have a look and see what that image is now. It should be this, yep. Okay, sorry, it's still loading. Hasn't improved it much. Colors are a bit more definite, if I can say it, much more bright. You can see all the purple, which didn't look. Now we need to go and play around with the color scheme. Now we need to go and play around with the color scheme. Okay, so let's use the inspector. Click on something blue and see what that blue means. Okay, let's have a look and see what the blue means. That means the build-up index. That's a worsening of the build-up. So blue is, yeah, that's a worsening of it. So what we want to do is to make that red. And let's make it then brown. And let's make it blue. Let's keep it that. Red, brown, blue, white, and green. So just make a note of it. And then we're going to run it. And let's see what it looks. I'll actually just put in code that these things don't pop up every time. Anyway, let's unselect them. Okay, so we're just going through them. It's not the optimum way of doing it. Oops, look at that. That's, geez, like it. That's hectic. That's hectic. That's hectic. So this is obviously doesn't look too good. You can see all the worsening. Blue would then be, let's click on blue, see what the blue means. Let's see what blue, okay, so let's click on the blue. So the blue should be somewhere around just about a positive increase, small increase. Still a decrease. No, it's an increase from 0.1, but you can see it's very small. So that's blue. So let's make that. Let's create another one. Orange. Create another one. I need to take that out. Don't need it there. Orange, right? Green. I'm gonna swap these two around. Green, and I'm gonna do white here. I'm gonna do white there and see if everything fits. Let's run it again. Let's then unselect all these other ones. There we go. Temporal difference. And let's unselect all these other ones. Okay, zoom in. Go to my place. There we go. In fact, I think one more last thing. I need to change the blue and the green. I need to change the blue and the green. Nonetheless, but I think you get the idea. Let's change that to green. And I'm just playing here to make it look a little bit more realistic. And that's the last change for now that I want to make. And I want to spend the whole video tutorial on, on um, changing this, playing around with the colors. I think you get the idea. Um, and you can play around with your own color schemes to see if you can make, there we go. That looks, I think, a little bit better. Yeah, that looks better. That looks better. So, let's see, that looks better for sure. Yeah, that looks better. So you can see the green is where there's been an increase in the buildup index. Now remember, an increase in the buildup index means there is more vegetation rather than less vegetation. Okay, so you need to get the interpretation correct. So in this case, when there's an increase in the buildup index, that means there's more vegetation and less urban and less sand. Okay. So this is quite important that you understand how to interpret these indices. Now, if you're not sure, go into these studies and go and read up on all of these indexes, and then you'll get an understanding of what a positive number means, what a small number means, what a high number means, what a negative number means. When there's an increase in the number, what does that mean, and vice versa. Because you have to be able to not just be able to calculate it and visualize it, but you must be able to interpret those numbers. So the green here would be an increase in vegetation, increase in healthy vegetation, increase in the mass of vegetation, i.e. a decrease in build-up area. So let's have a look and see how that looks. But now you'll see, now you have to drill in and you'll see there's green here. Now remember, this green doesn't necessarily mean it's vegetation. Okay, it means there was a decrease in build-up and increase. The green is. Let's have a look at it. We click on it. Sorry, click on it. I hope I put on the green area now. There's the build-up. It used to be 0.06 in 2018. It's 0.001. Oh, sorry. It was minus 0 in 2018, minus 0.16, improved to 0.1. So that means the build, sorry, where am I? It was minus 0 and it increased to 0.001. So that's the build-up index increased. So that means there's a greening of this area. Okay, so that means could be better gardens, uh, whatever the case might be, but it's certainly not an increase in a decrease in or increase in build-up areas. Now, let's have a look at, come on, it's just very, very slow. Okay, so let's have a look at, you'll see there's some red here. Let's have a look at what that red is, and we have to look at it at the Sentinel pictures. Let's have a look at the red is. You can see that sand. Build up temporary difference. That's that area here. The things are so slow. There it is. Let's have a look and see what was. Yeah, so you see that's build up area there. You can see that. And now if I go to 2018, okay, it's gonna go. You see, there's still getting this. Before I say there's nothing there, it's still loading. But you can see. Let's zoom in a bit. Let's make it. You see. Sorry, it's just very slow because it's Friday most probably. It wants to go home. He doesn't want to sit here with me hana-hanaing with it. So it's taking forever. Um, so you can see in 2018, there we go. That's 2018, 20, that's 2018, 24. Let's have a look at let's have a look at first of the build up. At the change in NDVI. Let's have a look at the change in the NDVI. There's the NDBI, and then let's look at the build-up change. Oh, these things are so slow. All these things obviously are connected. Okay, all these things are obviously connected because they use the same, very similar bands. So there should be a nice logical story between all these. There should be some alignment between these ones. Let's have a look and see. Build up index. You can see there's these reds there. But that's water. You can see there's a red here. That's water. Come on, sorry. It's just bombing out this whole thing. Let's have a look and see where there's place where there's definitely an change in build-up area. So let's have a look and see. There's Sentinel 18. It's so frustrating when this thing is so slow. It's very, very frustrating. It's immensely frustrating. Unfortunately, okay, so let's have a look at this area here. There's definitely an increase in build up there. That's for sure. Okay, so let's have a look and see what happened to the NDVI. So let's go first off the NDVI. Temporal difference. Remove that space there. See this brown. So this brownish color represents a decrease. This brown reddish color represents a decrease. So remember, it's still this area, this brown. So let's have a look at the build-up, temporal difference. Gives you a bluish color. That's so blue in this case is actually, we need to make it red. So we need to probably change. So let's make that blue and make this blue red. Let's see what that looks like and run. Okay, so let's see what it looks now. And that's how you're actually supposed to do it is find a reference point and then create your color scheme around your reference points because you know what has happened there in reality. So you adapt your color scheme, your images, you adapt according to that specific reference point. And that's the best way of creating this. And you'll see now it's red. You'll see there it's red. That's red. So that change, yeah, look, there's lots of other red as well, but It does. There's your red now. See, there it lies. There's the red. That's a road that they built. So the red is definitely a change in. So there's some areas here that's red. We know that there's quite a lot of new buildings that went up here. But unfortunately, it also still is quite evident with your sand. But it's more like a brownish red than a red itself. Anyway, I think you get the idea. Save, 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 save. I think you get the idea. Nee, I think you get the idea. Now, in the next video tutorial, what we're going to do is we're going to do thresholding for our build-up index. Where's our build-up index? We haven't done thresholds for it. Let's have a look and see. Have we done thresholds for it? Yeah, we've done thresholds for it, but let's leave that for a different video. Otherwise, it's going to get too long. But we're going to do the same, and we're going to do thresholding. We've got our minimum and maximum. We're going to obviously not make our thresholds those numbers. We're going to make it less than or more and less than these numbers, and then I isolate areas. And I'm going to use again the self mask where we're going to display that. So I'm going to keep that for a separate video. But now what we've basically done in this video is to generate the NDBI and the build-up index. Using our minimum maximums, we create visualization parameters. We change that visualization parameters a bit so that we creating images where we can identify features. And I said, a handy tip here is to, if you're not sure what the color scheme should look like, find a reference point on your region of interest that you know has gone from this to this, and then adapt the color scheme so that it presents that. And normally you want to use the brightest color, red or green, for that change. And this is basically just to fill up the bins. But that's a nice handy hint is to do that stuff. Okay, great, excellent. Thoroughly enjoyed it. Making good progress here. So yeah, many thanks. Thanks for joining me again. Appreciate your patience with me. I appreciate you joining me on this ride into remote sensing, the wonderful world of remote sensing. It's fascinating. I think you can agree with me. It's fascinating stuff. And please remember, for those that have already liked, subscribed, many thanks. Deeply appreciate it. It's a special place for you in my heart. And for those that haven't, please, boys and girls, press that buttons. It would mean a lot to me. It gives me motivation to continue with this. I really appreciate you. And please look out for the next one. It's around the corner. And as I always say, as I always say, I'll see you on the other side.